Hey there, NESMaker community. Kronos V2 back with the second episode of the assembly language tutorial, where we'll actually be tearing down a script. I actually had a friend of mine who, the last time he ever did any programming was IRC scripting. So yeah, I had him look at this, went over it with him to make sure that he completely understood every line. So hopefully this will be easy to follow. Let's get into it. We're going to be covering a fair bit. Going to be looking at numbers again, a few things to understand, what an opcode is, and then we're going to be tearing down two scripts. Then I've got a little challenge for you guys. After that, some tips if you're stuck or how to ask for help. And other places to study. I have said that out of order, but I've covered everything, so let's move on. Before we begin, I recommend either using Notepad++ with the user-defined 6502 language definition or Sublime Text with the MOS 6502 ASM6 syntax highlighting package. They're really useful. The Notepad++ plugin takes a little bit of extra work, but it does work. Though to be fair, an upcoming version of NESMaker is going to add built-in script editing functionality, so this might not be necessary later, but Sublime Text is awesome for allowing you to have a folder as a project. Sublime Text isn't free, but well worth the money. Highly recommended. Not an advertisement, though. I just say that as a developer. So, we're going back to numbers for a quick moment, just because it's good to go back over these things. Hexadecimal numbers represented with a $sign prefix. So $30 is hex 30. From here on, I'm probably just going to say hex instead of $sign. Binary numbers are represented with a percentage symbol, but we're not really going to see any of those directly in any of the scripts today. There is a binary operation, but it's not a comparison, and we don't need to look at its number directly. Numbers without a number sign, pound sign, hash symbol, whatever you want to call it, or a variable name points to a memory address. Pound hex 30 means the hexadecimal number 30, whereas hex 07FF means the hexadecimal memory address 07FF, which, by the way, is a great address to use for debugging in NES emulators. If you write a number to 07FF, you can see what you had just written in the accumulator, and you can, well, it automatically pauses emulation so that you can look at other locations in memory, just other debug information in general. Couple things to understand. Labels point to locations in memory. Variables point to locations in memory. When you see an invalid label error, you need to look at the line in the code specifically to find out if it's a label or a variable, because the assembler is going to treat them both as effectively the same thing. The first 256 bytes of memory, known as the 0 page, are also faster to access than the rest of memory, but I poked at one of the ROM files made by NESMaker, and it looks like there's a whole bunch of numbers sitting in there, and I don't know if they're used or not, so I would recommend not banking on the 0 page. There have been a number of people that have asked about conditional statements, and since we're just getting into code now, conditional statements, especially comparing numbers, for, that's implicit. Conditional statements, the more you need to check for, the more of them you're going to need, and it leads to a lot of rapidly inflating code. That's part of the reason why NES games reused so many animations. For instance, Ninja Gaiden only checked for ground state. If you're in the air, you have one slash. If you're on the ground, you have another slash. Mega Man checked when you were attacking, if you were moving on the ground, if you were idle on the ground, or if you were jumping. The question has been raised of what an opcode is. And the interesting thing is we don't need to use them directly. They're the underlying binary commands that get sent to the processor. And the assembler knows what opcode we're using based on the command and how we're using it. For example, LDA constant 03 or constant hex 03 has its own command, whereas a zero-page command has its own. But we don't really need to remember that because that's the job of the assembler. That's what ASM6.exe is designed to handle. Next, we're actually going to dig into a script. First, we're going to go into power up, increase health. The script checks if the player's health... I added an if there. The script checks the player's health plus 1, compares it to a maximum, and if the maximum hasn't been reached, increases the health by 1. It also passes the information needed to draw the new health value to the HUD and plays a sound. First, we start with the LDA command. Load into accumulator, or load accumulator is probably shorter, but into made better English. Code loads a value into the accumulator, either a constant prefaced with the pound sign, number sign, or a location in memory, a variable. Next, we clear carry because the next command we're going to execute is an addition. And it's important to clear carry because the carry flag gets added to the result of an addition. So if you do 1 plus 1, if carry is clear, 1 plus 1 equals 2. If carry is set, suddenly 1 plus 1 equals 3? It's led to some amusing errors and a little bit of confusion when I helped someone with code because I forgot to clear carry and suddenly every time they picked up a key they were getting 2 because carry was set. Next we have ADC, add with carry. The processor executes an addition operation on the number in the accumulator, setting the carry flag if it overflows past 255. In this particular case, we're adding the constant hex number 1 to the value we obtained from myHealth. A number prefaced with the pound sign is also known as an immediate. It's basically just a number baked into the ROM. Next, we're using the compare function, comparing the supplied number, in this case the constant number 4, to the accumulator and sets the carry and 0 flags according to the results. The interesting thing is the reason why it's setting these flags is because the compare command is actually a subtraction, but not storing the result. It's basically just a quick mathematical command. But rather than changing the accumulator, it leaves it alone. Next, we have a branch statement, branch on carry set. If the carry flag is set, then we jump down to skip getting health. If carry is clear, then we move on to the next line, which is transfer X to accumulator. We transfer the number stored in the X index register to the accumulator, and the accumulator's contents are replaced as a result. We then store the accumulator's contents, STA, into tempx. Next, we use the increment command, which modifies the number directly in memory without touching any of the registers. It's a nice quick operation, but there's one issue which you get to immediately. Incrementing a number does not put it in the accumulator. So if you use increment or decrement, you need to load the number again to do anything with it. Next, we're loading a number into the X register. In this case, the object ID of the player, or one object. As before, loading a number into a register replaces the value of the register with the new value. Next, we're storing your health, or the modified health value, into a variable. In this case, the object health array at the player object ID. So for example, if the player object is ID 2, then ID 0, ID 1, oh, we want to store it here at ID 2. The next block of code is used for the HUD update. We're storing the same value that we just stored into the player health value into the HUD element tiles to load variable. We're then loading the number 0 into the accumulator. We're storing that into HUD element tiles max. I can tell you that that is a counter which is compared to make sure that it doesn't draw too much of the HUD at once. Excuse me. Next, we load the draw HUD bytes variable into the accumulator. Now we use OR accumulator, which is a binary logical inclusive OR using the variable or value provided. What I mean by inclusive is if a number in either of the numbers, the accumulator or the number we're using with the command, if either bit is a 1, it stays a 1. Any zeros stay zeros. So in this particular case, we are turning the bit represented by HUD myHealth to a 1. Next, we store the result of that in the accumulator. We load the value that we stored in tempx into the X register with LDX, load into X. Next is the skip getting health label, which is where the BCS statement above would jump to. And then last, we use a macro to play a sound effect. As for conditional statements, we already covered BCS, branch of carry set, but there are actually a decent number of them. There are checks to be done off of a lot of the flags, actually. There's branch of carry clear, branch of carry set, branch if 0 flag set, which is BEQ, branch if equal. Branch if negative flag is set, branch minus, BMI. Branch if 0 flag is clear, branch negative. No. What? I have clearly typoed here. Oh, no. Branch if not equal. I apparently can't read my own text. I apologize. Then we have the overflow flag set or clear. Remember, branches have a maximum distance that they can load. Next, we can tear down the power up increase money script. This script actually changed a little bit from 4.0.6 to 4.0.11, but when we get there, we will show that modification. I'm using two increases because the main thing that I want to cover here is the major difference being the macro. We have an LDA command, which in this particular case, the assembler can help us because we want the hundreds digit of my money. So since HUD objects are stored as individual bytes, ones, tens, hundreds, add 2, you get hundreds. Next, we clear carry because we are about to do an addition. We add with carry the number 1 to the result. Of the hundreds digit. We compare it to 0A, which would be 10 hundreds, or 1,000. If we're greater to or equal, we jump to no more money, which just plays the sound. Next, we run the AddValue macro. But there's an error if you were jumping from 4.0.6 to 4.0.11. To keep from breaking things, it wasn't changed manually so that if you wanted to use the newer scripts and the changes that were brought with them, you modified this line, and that fixes the problem. This is a problem that I've noticed a lot of people run into, so I thought it would be a good idea to cover it here. To be fair, when 4.1.0 hits, this is probably not going to be necessary at all, but it's a good reason to show this would have given an invalid label error because there's a problem with a variable. Then we load the number 1 into the accumulator, store it in HUD element tiles to load. We perform the rest of the HUD update code here, loading draw HUD bytes, ORing the HUD myMoney constant with it, and then storing the result back into draw HUD bytes. We have the label, no more money from above, and then we have the play sound macro, which we jumped over earlier, but now we're going to look inside of it. As I may have noted previously, a macro stores, it's a quick shortcut for us, but it takes up the full length of its code in the ROM file, as seen here. This is the inside of the play sound macro. SFX get coin is fed to arg0, and then it runs through the code. We load into the accumulator the value arg0. We store it in the SFX to play variable. We load the fire sound byte variable into the accumulator. I discover I was mistaken, and we are actually going to do something with binary. In this particular case, we are ORing the second bit into the fire sound byte variable, storing it, and then ending the macro there. I'm not quite sure what fire sound byte does, but it's the part of the sound engine, so further practice and study. This is a very short list of the resources that I use to get to where I am now. If you've had any difficulty with any of my explanations, Easy6502 would probably be a good place to look. If you need a command reference, you can get that at obelisk.me.uk. And using all of this information combined is exactly how I got to where I am now. If you're stuck, the best way to get help is to gain the when asking for help on any site, post clear error messages. Command prompt windows, like the export and test menu item, have the ability, by dragging a box around what you want to copy, right-clicking the title bar and clicking edit, then copy. Sharing the code around the error message also helps a ton. It's a whole lot easier to help fix an error when we know what the error is actually pointing to. My line 6 might not be the same as your line 6. I can point you in the general direction, but I can't tell you exactly what's wrong without seeing the code. In that regard, the more things you keep secret, because, everybody has their pet projects, the harder it is to get help. So the more useful information you want, the more information you have to provide. Also, I'm going to really discourage cell phone pictures for trying to provide errors. I've seen that a whole bunch on Facebook, and I've honestly wanted to help, but I have an eye problem, so there have been times where I've tried to zoom in and it's still a blurry mess. If you need to take a picture of your screen, there's a piece of software called GreenShot, which is free. And you can use a cloud transfer service like Dropbox or Google Docs, not Google Docs, Google Drive, iCloud, or OneDrive to post the picture online. If you can't use Facebook from your computer, I understand needing to use the phone pictures, but I'm just sort of throwing it out there that my ability to help will be rather limited. Last but not least, asking for help, even multiple times, even 100 times, is perfectly fine. We're all learning new things in this process. And if you don't ask, you don't necessarily get an answer. You don't necessarily make any progress. The forums have a number of helpful people, and you can share code much easier there than you can on Facebook. Next, and lastly, I have a little bit of a challenge for people. I have created a template that I want people to use for this. As a coding challenge, I want you to write a piece of assembly code that increases the variable myMagic by 3 every time it's run. But if the number goes higher than the number 25, hex 19, it sets the myMagic value to 25. Again, hex 19. I will be linking the paste bin link in the description. You can also get it from within the presentation, which I will be sharing, so that you can page through this without my rambling and stumbling over words. And as a hint, you're going to need to use the jump command to skip to the end of the script. The syntax is very similar to a branch, only it's always a jump. If the code encounters JMP, it always jumps. Also, because I'm suggesting to do this using Easy6502, do not use the AddValue macro. AddValue. Well, also do not use AddValue for the purposes of this if you were going to try to code it in NESMaker and just show the results of the accumulator. Because AddValue splits the number into bytes. If you get the number 324, you don't actually, well, first off, that would overflow a byte, but if you were to get the number 108, for example, instead of being 108, it would split to 108 into separate bytes, and that takes a decent chunk of effort to actually check. And with that, we've reached the end of this particular tutorial. Next time, I want to look at other pieces of code, but specifically, I want to go over jumping, subroutines, conditions, and branching. Another topic that people have wanted more information on, and I want to provide as quickly as possible. That being said, that concludes the second tutorial. Have a fantastic day, night, wherever you are, and I will see you next time.